Welcome to Weird Science. Weird Science. Hey, Barbie. Hello, Barbie. Let's go party. Usual amount of weird. Usual amount of weird. It's like I hope everybody is coming in here and want to learn about some cool stuff. I don't know if anybody keeps up with the SpaceX news, but lots going on there. Pretty interesting stuff. And guys, if this is your first time here and you haven't favorited me already, make sure you smash that favorite button. I really do appreciate that. Hold down those hearts and send comments. It doesn't cost you anything to comment and send hearts. Please do. Two past three. All right, let's. And here we have the SpaceX.
All right, there we heard our launch director give the final 30 seconds. Here we heard the launch director give our final go for launch. And at this point in time, all systems are go.
All systems
are
go.
Now and watch as Falcon 9 takes our stack of Starlink satellites and 2 ride shares into space.
10,
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
And liftoff.
It's Falcon 9 with 60 of the Starlink satellites going to low Earth orbit. Now, this is a replay from a couple days ago. It was a successful mission. Such cool views, especially when it's really clear. Hey, Art Man. Right? It's got such a good track record too. These.
As you can see, Falcon 9 successfully lifted off from historic launch pad 39A at Kennedy Space Center.
It's actually YOU_RE.
To orbit. We throttled the engines down in preparation
You
for
are,
Q,
not
or maximum
your.
aerodynamic pressure. This is the largest structural load that the vehicle sees during supersonic. This is the largest structural load that the vehicle sees during ascent, so slowing the vehicle.
I'm an engineer and scientist, and
Max Q.
Max Q is the maximum dynamic aerodynamic pressure.
And we're going to have 3 events happening back to back. First will be main engine cutoff, or as you'll hear it called out, MECO. This is where all 9 M1D engines shut off and slow the vehicle down in preparation for the second event, stage separation. As the name suggests, this is where
it is
the
SpaceX.
first stage separates from the second stage, with stage 1 starting to make its way back to Earth for landing on Earth. While stage 2 continues its journey with the third event, SES1, or second engine start 1. This is where MVAC will light up and begin to propel the second stage along with the Starlink and 2 rideshare satellites into orbit. Just a few seconds ago, we heard the call out that MVAC chill has begun. That's the same thing as what I described prior to liftoff for the N1D engine.
So that's pretty
We
cool.
blow a little bit of that super chilled liquid oxygen into the turbo pump of the MVAC engine, helping to prepare the process.
It's a liquid. It's a mixture of RP1, which is like a Carolox, and also liquid oxygen. So the first stage uses that, same with the second stage.
So there we can see that the engine
Separation confirmed.
Stage separation.
All right, so on the left-hand side of your screen, we got the first stage, and the second, on the right-hand side, the second stage. And there we heard call out evacuation.
Hey,
You
Chef.
can see that nozzle begin to develop a lovely orange glow as Earth rotates in the background. On the left-hand side, we got first stage.
Potassium nitrite.
Grid fins in preparation for
That's what I'm
the
looking at.
drone ship landing. Just a few seconds, we're going to have fairing deploy.
So solid rocket motors are pretty cool.
And that's our first view inside the payload fairing.
There we go, fairing
Where we
deployment.
have visual and call out there that fairing separation has occurred. As a reminder, we will be attempting to recover those fairing caps
Potassium
today with our
nitrate,
recovery
boron
ship,
potassium
Sheila
nitrate.
Bordelon. And of course,
Cool.
we're going to be recovering the first stage of the drone ship. Utilize a view for today's recovery attempt.
So you notice the grid fins there on the left-hand side.
Acquisition of signal for
Left-hand side, this left. Or maybe that's
As stage 2 heads towards its targeted drop-off orbit, stage 1 will execute 2 burns in order to make its way back to Earth. The first is the entry burn, where 3 of the Merlin 1B engines will reignite. This helps to slow the stage down as it re-enters the upper part of the Earth's atmosphere. The second burn is the landing burn.
landing burn.
and this is a
That's
single
one
engine burn that
engine.
brings the vehicle speed down rapidly in order to land on the drone ship.
So what's cool is that the second stage there on the right, up here, it uses the exact same engine as the lower stage, except for that giant glowing red bell that you see. That bell, engine bell, it's designed to make sure that the air is properly expanded, because you got to make sure that it's not over or under expanded when you have rocket propulsion.
Low Earth orbit at around 550 kilometers. Most satellites are around 36,000 kilometers in altitude at GEO or geostationary orbit. When satellites are further from Earth, the round-trip data time between the user and the satellite, also known as latency, is much higher, resulting in poor performance for activities like video calls and online gaming.
Yeah, it's gonna be really cool once they get Starlink up and it's fully running and functional. And I think that we're gonna see some neat
On
stuff.
the left-hand
Sure.
see the first stage is
Thank you for the favorites.
Falcon 9 is equipped.
Hey guys, if it's your first time in here and you haven't hit that favor button, please do so by smashing that star
The
up
stage
above.
uses nothing but the grid fins for steering as it makes its return to orbit.
And those grid fins there on the
Navigate the
left.
rocket during the entry and guide the rocket during descent. Occasionally, you'll also see some white puffs. These are nitrogen gas bursts for attitude adjustment and control.
For the RCS, rocket or ratchet control system. Nitrogen gas.
Now we're about
You
20
can see those little white puffs, like
entry burns. As a reminder, this is a 3-engine
there it goes
burn
again.
that is meant to slow the first stage as it hits the thicker parts of the Earth's atmosphere.
And then those grid fins, like as they get deeper into the Earth's atmosphere, it actually causes, like, it's able to adjust its attitude and control where it's going. It's pretty awesome. That China rocket landed in somewhere in the Indian Ocean.
And they do all that entry burn.
Entry burn,
And we
and
just got
then
a confirmation of stage 1 entry burn cutoff. Now we're about 60 seconds away from
HRT.
landing, and at this point, the vehicle's traveling around 900 miles per
current
hour.
lock.
This really puts the
Down.
acceleration into perspective. In the span of
Hi.
a minute, we will have slowed from twice the speed of the jet all the way down to 0 as the rocket lands.
Yeah, it's
There are
pretty
more
impressive.
events
Like,
scheduled to happen in close proximity here. Stage 1 landing burn will begin and will finish its burn in about 25
and
seconds.
then it'll be the landing
And
leg
then
deployment.
Stage 2 up in space will stop firing about 15 seconds later, at which point we'll enter the first coast period. So prepare for that in about 45 seconds.
Thank you.
Stage 1 is transonic.
transonic, that's below supersonic, below the speed of sound, but still like kind of high. Yeah, it is fast. Like the aerodynamic like forces that they're feeling right there. Think about, and you're driving down the highway. Thank you.
May lose coverage of
You're driving down the highway, right? And you stick your hand outside of the vehicle, right? And like it blows your hand back, and that's like a lot of pressure. Look at this, it's so cool. Oh yeah, perfect landing. It's like that's like a bullseye.
A beautiful view of a successful landing.
Yeah, look at that.
84th successful recovery of an orbital class rocket, and the 6th recovery of this particular booster.
Yeah, so imagine sticking your hand out this. Like, this is the forces that this is feeling. And it's going super fast. So.
And there we had second engine cut off one.
It is.
So one.
SpaceX does these pretty routinely. It's beginning to get a little bit boring and kind of thinking, like covering these space launches. Like they're like almost every week. I feel like.
Now, stage 2 is going to coast in this orbit for the next 45 minutes or so. While that happens, take a look at this animation showcasing where we are in the coast phase. We'll see you back here at T plus 54 minutes for a second stage relight and the deployment of...
Welcome, Vodka. How are you? Well, that's good. Going into the next phase of space travel. And that is super awesome because, you know what? We're going to be exploring other planets. We already are. We're on Mars. We've had our first off-world flight, powered flight. It's pretty impressive. And everybody, welcome. This is Weird Science. I'm your host, Mike F. Bell. And right now, we just covered the launch of another 60 Starlink satellites by SpaceX with the Falcon 9. That was successful. They recovered the first stage booster and landed it on the drone ship. Of course, I Still Love You. And that's awesome. It's going to fly again another day. Thank you so much. I really do appreciate it. You've been hoping, praying for vodka to get up to that. Vodka's awesome. Hey, Dante. Welcome. Everybody, if you are just joining, this is Weird Science, and I am Mike Bell. We just covered the launch of SpaceX's Dante, welcome. But what's going on here is right now it's in the coast phase, so the second stage is drifting slowly up towards its apoapsis. The apoapsis is the highest point that the trajectory is going to reach. So what they do is once they're like within a couple minutes of their apoapsis, like the highest point, they turn their engines back on, and that causes them jet. Thank you. But anyway, so what causes that is they are up at the apoapsis. That's the highest point of their trajectory, and then they turn on their engines, or their engine. Sorry, there's one engine at the second stage, and then they increase their thrust, and that causes the opposite side of their trajectory to increase. So their periapsis increases, and eventually that periapsis is big enough that it actually encompasses the whole orbit of the Earth. So it's pretty neat. Thanks, Jose. Thank you for the favorites. If you guys are just coming in and this is your first time here, this is Weird Science. I'm your host, Mike F. Bell. Every week we talk about different science topics and different space topics. So right now we're covering the launch of SpaceX's Falcon 9 with 60 Starlink satellites. It's part of the global network that's in low Earth orbit that's going to enable low latency, high bandwidth transmission of internet and broadband. It's going to be absolutely amazing. And the tests that they've already started doing with the limited network that they have up there, they found that the latency is even lower than they were originally estimating, as well as the speeds are higher than they thought they were going to be. So it's good things all around. And what Starlink is going to do, it's going to bring internet to areas that did not have broadband. Like, it's kind of expensive when you look at connecting people to the broadband internet. That last mile is the most expensive. It is actually what made Google Fiber not work, because it just got so cost prohibitive that the economics made it not viable. If I want to go to the moon, I want to go to the moon as well. That'd be great. I'd love to go to the moon. I would love to go to space. Like, I was thinking that Blue Origin, that's Amazon, Jeff Bezos, Blue Origin. They have New Shepard, and New Shepard is their suborbital vehicle right now that launches, I think, like 6 people up to 100 kilometers. 100 kilometers, that's the definition of space. That's the Kármán line. Kármán line is where you actually become an astronaut. So it's pretty cool. So if you could afford it, you could become an astronaut by signing up with Amazon and getting on their New Shepard. So maybe if you guys send enough diamonds, I'll go afford to go on the New Shepard. I think it's like $100,000. Yeah, the fiber, the last mile is always the most expensive, but like this enables them to reach areas that couldn't be reached by traditional methods. Pretty cheap for the opportunity to go to space. I agree. I think it's going to get cheaper. I mean, like everything, it gets cheaper. And Super Eric, welcome, sir. If you're just joining, this is Weird Science. I'm Mike F. Bell, and we're talking about space right now. This is SpaceX's Starlink satellites, and they are actually, there's a whole bunch of them. I think there's something like over 2,000 of these things up in low Earth orbit, and the network is getting bigger and bigger and more powerful, which is pretty impressive. Thank you. I agree. Space travel is going to get cheaper, especially with so many people and private industry making great strides in development of these vehicles. Like, you look at SpaceX and their Falcon 9, it's able to deliver satellites into orbit, no problem. They have such a low failure rate that They're like the most reliable company out there. Thank you for the balls. Slow Crush, welcome. Welcome, Dazzle. Dazzle. It better. I want a ticket to orbit the moon. Do you know that there's actually going to be a mission that SpaceX is doing with their Crew Dragon? The Crew Dragon, the same module that delivers astronauts to the International Space Station, it has the capability to fly around the moon. So it's going to fly around the moon, and some people are lucky. I have not gotten the Tesla yet. I'm waiting for it. It's still sometime in June when I'm going to get delivery. What's up, Z? Welcome. How are you, sir? Das no. Hello, Mike. Hello, Slow Crush. How are you? I'm doing good. Doing good. We just watched SpaceX put another 60 of the Starlink satellites into low Earth orbit. So, good stuff. Good stuff. My daughter, the vacation to the moon. 2035, right? That's probably when it will happen because, like, I feel like space and the commercialization of space is following that same trend as, like, the internet and computers and, like, Moore's law with, like, two. Yeah. So what's going on is 1, 3. 1. 2. 6, 5, 8. I said I didn't say 8 or 7 or 9. It's like 12. So I'm not playing Dungeons and Dragons, I swear. 2. Alright, so let's see. So I think I'm going to skip ahead to the part where they get up to orbit and turn on their rocket. It's like 26,215 kilometers per hour. So that's like 18,000 miles per hour. You have to be going really fast when you're going in space. Really fast to maintain orbit. See, I would like to launch my own satellite one day. That would be pretty cool. There's like
welcome back to our webcast.
All kinds of regulations. I looked into it actually.
Missions so far this year. As a recap, we've had an on-time liftoff from our Kennedy Space Center Pad 39A. Our first stage booster landed for its 8th time and 84th recovery overall. Stage 2 completed its 2 burns, and we deployed our 2 ride shares. One correction on the deployment sequence. The first deployment was for our customer tieback, and the second deployment was for our synthetic aperture radar satellite for Capella Space. Now that we're coming up on deployment of our Starlink satellites into low Earth orbit, or LEO,
what's the maximum or minimum? Sorry. What's the minimum velocity to maintain orbit? So, like that low Earth orbit that they're in right now, it's around 17,500 miles per hour. So that means, so here's the deployment of the satellites.
Now you can see the satellites, the Starlink satellites out in space, drifting away from the second stage. As a reminder, this is just their drop-off orbit. Shortly, they will deploy their solar
Yeah,
array,
the speed of
and
light
they'll connect
is very,
to
very
themselves to
fast.
each other and use their onboard
So-
ion thrusters to make their way into operational orbit.
I'm not sure what the conversion
And
is,
with
but
that, we'll bring our webcast to a close for today.
I know that the speed of light is 300 million meters per second, or 300,000 kilometers per second, which is so incredibly fast. And the problem with the travel, once you get close to the speed of light, is the laws of general relativity, and like you have a lot of problems with the time and space, and it warps. So if you go really, really fast, your time goes slower. So that means that if you were to travel at the speed of light for however long, what would seem like a short journey for you would be a really long time for the people that were here on Earth. So you'd actually come back and find that like everybody that you knew was either dead or really old, depending on how long they were gone. It's and scientists have shown that there's an actual difference from when you're going faster, and they've done this with atomic clocks on the International Space Station versus atomic clock on Earth, and of course the one on the ISS is going way faster. I don't know what time it is. It's all kind of incredible to fathom, and I don't pretend to know even the slightest bit about this. But you know what? It's fun to think about. And guys, if you're just joining me, this is Weird Science. I'm Mike F. Bell, and I'm your host. If you haven't hit that favorite button, please do so. Hit that favorite button. Thank you, June, for the favorite. I appreciate that. And guys, questions, comments, whatever. Comment, question, go ahead, do it. Send those hearts, send those diamonds. Let's learn some science.
We do indeed. Hello, everyone.
All right, so alrighty, let's go do this. Go on to the next thing. Weird science. Hey, Cruise Lover, how are you? Nice to see ya. Hey, you're welcome. I'm doing really well, thank you. Mint, yes. Thank you for this platform. No problem. Thank you, Mint. You're totally welcome. So, we talked about SpaceX and the launch of another batch of Starlink satellites. So next, I wanted to delve into the next topic, the interest, and that would be metals. Specifically, strange metals. So what I have is a bunch of strange metals. Yes, mercury is a strange metal, but it is unfortunately toxic and dangerous, and not something I want to be dealing with. So we will not be dealing with mercury, that's for sure. And if anybody has any mercury, I recommend that you don't touch it. So what we're going to look at is some metals on the periodic table. And let's see here. Oops. Try that again. Good. Pull up my periodic table here. Periodic table. Everybody knows what the periodic table is. Maybe yes, maybe no. This is it. It's a very impressive thing, and people that are chemists could totally explain it better than I can. But today, what we're going to be talking about is some metals. And those metals are here. All right. So, that's my first graph. Up here, we got cobalt, nickel, copper, and then zinc. And then next to zinc, over here with this, in this group 3A, see that, the column right here? This column. Just because lead is heavy. That's really the only reason. It's dense like other. The density of lead is very high, and so is 113. It's like maybe excuse me. If I can get some of that, some unobtainium. No, I'm not. Those down there, all those are pretty rare, and they usually create it in a laboratory with like super colliders and stuff that I don't have, so wouldn't last. All right, so I didn't tell you what metal. Okay, see this one right here, this one in blue, it says gallium, number 31. Gallium, number 31. That is something that we're going to be dealing with today, so I hope that you brought your learning hat. Cobalt, nickel, magnesium makes for battery chemistry for electric vehicle battery cells. So is iron, phosphate. It really depends, because a lot of the problems with batteries is they end up with dendrites, and the dendrites cause like these tree-like kind of structures to burst through the cell, and it basically damages the battery. Magnesium is a whole lot of fun. Mike Bellium. Okay, so gallium, that is number 31. Below that, we have indium, number 49. Okay? So those are the two elements that we're going to be looking at, and it's kind of cool what they do. So you may not know this, but gallium has a relatively low melting point. So it melts at 86 degrees. So 86 degrees Fahrenheit. Okay, yeah, I'm not sure, but let's continue. Alrighty. So I have some gallium. Some gallium, like I was talking about earlier. And this gallium, it's solid at room temperature. So this is solid. But the cool thing is, you can actually take it and heat it up a little bit in some water, and it's enough to increase its temperature such that. Hold on one moment. Just a moment. All right, so look, I got a little bit of water, and now I'm going to take that water and put on my hot plate, turn the power on, and start heating that. What I have next is the metal called indium. Now, indium is below gallium, and it's kind of bendable. Like it's a more pliable metal. Like I'm able to bend this chunk a little bit. I hope everybody can see what's going on. Okay, so that's indium. Lithium batteries. Yeah, who knows? So this is, I'm not entirely sure. The bottom camera needs to be higher, Mike. Okay. Okay. I'll fix it. It's like the problems of trying to run multiple cameras. What's that? That works. I think I need to see what's going on over there. I think, yep, sort of. There we go. Can we get a round of applause for Mike F. Bell and his amazing camera setup? It's like, I challenge you to find one other streamer that is doing anything like this. Thank you. 100. What Model S? Yeah, it's a dust filter. True, Mike. Not Mike G. Bell, Mike F. Bell. Yeah. So, let's see. Where am I? On here. There we go. Okay, so here's something neat. Like, I got some gallium here, and I'm hopefully heating this up. It's slowly getting heated. I have it on the hot plate, and it should melt soon. What I did in advance is I actually mixed some of that gallium and indium together in a ratio of 2/3 gallium to 1/3 indium. And what actually happens is it causes that metal to just melt. So check this out. Yeah. That's pretty awesome. Like it, Super Dead Kevin, what's up? Galvanic series. Yeah, like that galvanic force is something that is the difference in charge kind of the metals. So you could actually look at different metals. Like if you have copper and zinc, you could actually put those into an electrolyte solution like vinegar with a little salt in it, white vinegar and salt, and you could create a battery because of that galvanic force. It's all about differences and stuff. But here's something neat. I'm waiting for this to melt. Taking longer than I wanted to melt, but it's melting. But here, let's take a look at this. This right here. All right, so this is that mixture of there we go, right up there. There we go. Well, you can see that what happens when you take these two materials and combine them together is they start to become liquid. Like there we go. I got a little bit right here. We'll just pour this out on this tray. Like the thing with gallium is it's dangerous actually because it will combine with aluminum and make aluminum incredibly brittle. So what I have here is an aluminum sheet, and I'm gonna scrape it up pretty good. Just a minute. Go. I'll put a cool. Like that. And what I'm doing right there is just scraping off a little bit of the aluminum oxide that's on the layer. Aluminum is reactive with oxygen, so what happens is it oxidizes and you end up with a little coating of aluminum oxide. But what I did there was scraping a little bit. Let's see, this is kind of long. It's getting there. It's definitely starting to melt. We have gallium and indium. That's a mixture that I made right here. Actually, pour a little bit out so you can see it. Buddy, I'm live. Yeah. Look at that. All right, bud.
That's a piece of gum.
Hold on. No, I'll give you a time. Is there a request?
Yeah, it did.
I forgot to say it, actually. All right.
Also,
That's it.
It's just a piece of gum.
I don't have, actually. I don't. Really. All right, so.
Red gum?
All right, and everybody, if you're just joining me, welcome. Careful. What did you do?
I did that.
Good. Plug it back in. Over there.
I don't know which
Just
floor
push.
it is. I don't know which floor it is.
There we go. Sorry about that. Power. Yes. Kids want everything, right? So anyway, what we got here is you can hopefully see what's going on. But look at this. This is some of that liquid. It's liquid metal. It's very liquidy and like. So, like, look at that. Like, he could actually make it run. And the thing about gallium is it's going to get into this aluminum and really destroy it. So, hopefully you'll be able to see a little bit of that, but no worries. And guys, if this is your first time in here, this is Weird Science. I'm your host, Mike F. Bell, and we're talking about gallium and indium. Two metals that are on the periodic table that are pretty interesting in my opinion. Welcome, Trouble. Welcome, Miss Disney. Hey, Miss Disney, how are you? My brother would love this, for sure. So check this out. Look how liquidy this is. It's like running all over the pan. And like the thing about gallium and indium is, even if you get them on your fingers, whatever, it's not gonna hurt you. They're non-toxic. It just stains your finger, kind of similar to the way graphite does. So let's see our gallium. It's starting to melt. Yeah, so you can hold it. Yeah, watch. Here. Watch. Here, put it, watch. There. And pour a little in my hand. There you go. See, it's going to stain my hand, but it's not toxic or anything. Hopefully y'all can see what's going on. It's an interesting metal. Let's see that, and then I'm going to pour it back in my container. And then hopefully you can see the see. Just stains your hand a little bit, just because of it's kind of similar to the way graphite is, or lead, but lead, as we all know, is not the safest thing to play with. Neither is mercury, but gallium and indium, they're okay. Probably not to drink or anything like that, because I mean, you never want to put lab chemicals in your mouth. It's not a good idea. That's what LEDs are made from, right? Yeah, the gallium nitrite or nitrite. I don't remember. Where can I get some though? You can get some actually on Amazon. Just search for gallium and search for indium. Indium is a solid metal just like this, and gallium is a solid metal too. It's starting to melt. Gotta leave it for a little bit longer and then we'll see what happens. But what's pretty cool is you could take the gallium, right? The gallium melts at a pretty low temperature, but at room temperature, it's solid. If you raise it above 86 degrees Fahrenheit, it becomes a liquid. So that's what I'm doing right now. I have a guy on the hot plate with the so it's all getting built. Whoa. Legally medicated, of course. Wouldn't have it any other way, my friend. Wouldn't have it any other way. So my gallium is taking an awful long time to melt, but hopefully it will do some melting sooner rather than later, and we won't run out of time. This is Weird Science. If you're just joining me, and we're playing with some metals. Got a mixture of gallium and indium. So when you take the gallium and you combine it with the indium, you end up with something that lowers the freezing point. Lowers the freezing point of the gallium. So similar to the way ice works. When you have ice and it's out on your sidewalks, right? You take salt and you throw it on the sidewalks to melt the ice. That's because when you lower the freezing point of water, I believe. I don't know if you're saying that wrong because I'm not sure. Did you hear what the guy? That's funny. True Leave is awesomeness. You guys, we are playing with gallium and indium, two metals that are pretty cool. Alright, so let's see. See if these metals are melty yet. Alright, that's actually kind of melty. Look at that. Yeah, it's melty for sure. It's actually a liquid now, so check this out. We'll pour a little bit onto the aluminum. Here we go, look at it. Definitely liquid. So gallium will melt at a low temperature. Like this is, it's a relatively low temperature. So I'm just spreading it here over this aluminum. Or aluminium for our British friends, Australian friends, and anybody that says it that way. And guys, if you're coming in for the first time, make sure that you smash that favorite button. My name is Mike F. Bell, and this is Weird Science. I only have a few minutes left before my time is up. Probably about another 10 minutes or so. And I encourage everybody to favorite me. Hold those hearts down. Send those diamonds if you feel like sending diamonds. I really do appreciate it. So, check this out. It's already like starting to get a little weird. Now, if I leave this, I don't know, a couple of hours, this will actually disintegrate. So be sure to favorite me here and also favorite me on Instagram. Same username as here, Mike F. Bell. I'm on Instagram, and I'm going to leave this experiment with the gallium on here, on the aluminum, and I'll be posting some updates about what happens to the aluminum. And just so you know, the aluminum and gallium reacts with aluminum very easily. It's already starting to happen a little bit. So this, I'm trying to just put this gallium into the aluminum. But what will happen is the crystal structure on the aluminum will actually be disrupted by the gallium. The gallium will force its way into the aluminum, and you'll have a crumbly aluminum. That's why aluminum and gallium don't mix. And gallium is highly restricted, so you can't have it anywhere near airplane or anything of that. Danny Bravo, welcome. Wait, see what's going on? This is actually liquid metal. Like, this is gallium. I heat this gallium up to its 86 degrees Fahrenheit, and it's turned into a liquid. Now, here is something cool. I got that indium, and we're going to mix the indium and the gallium, and that lowers the freezing point. Lowers the freezing point of gallium and causes it to melt. So you end up with some melted gallium, and it's awesome. And guys, if this is your first time around here and you haven't hit that favorite button, please be sure to smash that favorite button. I really do appreciate it. This is Weird Science. I'm your host, Mike F. Bell, and we do this every week. So I like to talk about different science topics, and I always break down the latest in space news. So if you want to find out what's going on in space, tune in every Wednesday at 3 p.m. Eastern, 12 p.m. Pacific time. It's a good time, and I hope that you bring your learning hats and your goggles and learn a little something. Gallium is a metal. It's a metal on the periodic table. It's something that melts at 86 degrees Fahrenheit, which is, I've got a little bit of it on here. And you can see now what's happening is this aluminum is actually starting to react with the gallium. So what's going to happen, you'll see, is the gallium metal will impregnate the aluminum structure and make it very brittle. So follow me on Instagram if you haven't done so. I'm going to be posting updates about what's going on with this gallium and aluminum. So we'll be keeping an eye on it, and if you want to find out more, watch what happens with this. It's very cool. Is this how they melt other metals? No. No, they melt metals with heat. So this right here is just like a cool little science trick, because gallium is a great thermal conductor. So they use it a lot in the manufacture of PC components and electronics, what have you, and it's good for its thermal conductivity. The thing with gallium is its electrical resistivity changes a little bit when it's liquid versus solid, and it's a better thermal conductor than it is an electrical conductor. Thank you, Ems. Yeah, interesting stuff. So this right here, you can actually see a little bit, maybe this camera. starting to turn black, actually. Right. So this is like turning black right on there, and it's starting to react with the aluminum. And what's kind of cool about this too is I can take a little bit of water and add to this, and the aluminum right here will react with the water and create hydrogen gas. So it's pretty cool. Hey Lisa, how are you? Hydrogen gas, yes. The so you have the gallium and the aluminum, and then that makes it so the aluminum is able to react with the H2O. So H2O, it breaks down, and you get the hydrogen, oxygen, and you just get a bunch of hydrogen gas. Get ready for bubbles. Squeaky ball. Should have paid more attention to chemistry. This stuff fascinates me. Awesome. Well, if you guys are just coming in here and haven't hit the favorite button, be sure to smash that favorite button. So look at this. This is definitely starting to react already. Turning kind of black. Black as the sun. What have I done? I feel so bad. I feel so numb. Yeah. And thank you. I feel like I'm watching Breaking Bad, except I don't make meth because meth destroys lives. Anything's evil. Anything is easy to make. If you have the right precursor chemicals and the right equipment, you could do, and the know-how. You have to have the know-how. But if you could follow steps, it's like chemistry is kind of similar to like baking, I guess. It's like measure the ingredients and then combine them in the right way and then heat it. The most fascinating reaction to make, to observe. That's a good question. I like making power from just like copper and zinc and some white vinegar. I could actually make a battery fairly easily. It's cool. That's fun. Thank you. I'm glad your son enjoys my show. Thick Barbie son, welcome. Nice to see you. It's like stay in school. It's important that you get your science and math understanding. If you could do well in science and math, the future is yours. Science and math and technology and all that, STEM, science, technology, engineering, and math, those are the future of tomorrow. They're the, be a nerd. Be a nerd. I'm a nerd. And being a nerd is awesome. So if you don't know a lot about science, get interested. Like, start watching my show. Come out and see stuff about science, because everybody is a scientist. All that it takes to be a scientist is to be able to ask why. If you could ask why, you could be a scientist. Melanie wants to be a scientist. Awesome. Yes, curiosity is super important. I'm a roofing scientist. That's awesome. I came in late. What are you creating? Yeah. Oh, basically, I have some gallium. Gallium is a liquid at room temperature, or I mean, solid at room temperature, but at 86 degrees, it turns into a liquid. So I've got some liquid gallium there, and that's right here too. I actually have a little bit of indium. And it starts to melt the indium. Yeah, look at that. It's like starting to melt the indium. So I've got a bunch of the liquid metal. There we go. So indium into the gallium, the indium and the gallium. The indium acts to lower the freezing point of the gallium. And what happens is the gallium melts. It melts at a lower temperature. And then right here, I wanted to show how gallium is actually a really cool chemical, or a really cool element, but it's reactive with aluminum. So, as you all know, airplanes are made of aluminum. So, gallium and airplanes, no gallium around airplanes. It's highly restricted. Thank you for the favorite. Exactly. It's like Bill Nye the Science Guy, only I'm cooler and better looking. Yeah. Hey guys, I'm actually out of my time. Like, I gotta conclude. So, I gotta end this before it's too late. So, thank you so much for joining me. Thank you guys. I appreciate it. And you guys are awesome. Be sure to stick around. Like, now is the time.